Good morning, guys. Couple problems here. This actually one is a homework problem. I think number 10 is not, but what you want to do is you can get this graph that you see here. This is right on number 9 on page 136. So get that copied onto your note sheet quick. And please, 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 as you do it, make sure you understand that is velocity. That is the graph of velocity, which we really need to know. And looking at that graph, what we're going to do based on our horizontal or whatever motion problems we have, we're going to look at this graph. You see we have no function this time. We're going to look at the graph. And when does the particle move forward? When does the particle move backward? When does the particle speed up? When does it slow down? Well, when I'm thinking about velocity, when I'm looking at the graph of velocity, okay, my particle, remember from yesterday, when the velocity was positive, I was either moving upwards or I was moving to the right. So I'm moving forward when v of t is positive. So when is v of t positive? Well, the intervals in which it's positive from 0 to 1. It's also positive from 5 to 7. And those are the only two intervals in which I'm positive on. So the particle is moving forward on those two intervals right there. Well, when am I moving backwards? Well, if I'm thinking velocity, when I'm moving backwards, I'm moving to the left or down, either way. But either way, that is when my v of t function is negative. Well, when is v of t negative? V of t is negative all the way from beginning at 1 all the way to 5, because I can see those are all negative values on my velocity graph. Okay? When is it speeding up? Well, remember, when we're looking at velocity, speeding up is when v of t moved toward the x-axis. So when is it moving toward the x-axis? So I can see up here, I'm moving toward the x-axis, because remember, we got to read it left to right. So it is speeding up. Oh, hold on. Back up the train here, little Smoky. Back up the train. Let's get rid of this. Let's get the right thing in here. When we move toward the x-axis, we slow down. When we move away from the x-axis, we speed up, because when I move away, like here, when I'm moving toward, my quantity of velocity is getting less. So when I'm moving away from 1 to 2. Now I can kind of see here between 2 and 3, I'm not moving away. My velocity is just kind of constant there. It's just moving along. Then from 3 to 5, well, I'm going towards it, so I must be slowing down there. But from 5 to 6, okay, from time interval from 5 to 6, I'm moving away from it. Then I move back towards it, so I must be slowing down again. And then I'm just kind of constantly at rest there because my velocity is 0. So slowing down, these are the two intervals when I speed up. Slowing down is when v of t moves away. Ah! Boy, am I dumb. When I move toward the x-axis, okay? Because when I move towards it, my velocity quantity gets less, and when I move away, my quantity of velocity becomes more. That's why it's speeding up, slowing down. So I'm moving away, or I'm moving towards it, holy crap, from 0 to 1. I'm also moving toward the x-axis from 3 to 5. And I am also moving toward the x-axis from 6 to 7. So that's my forward, backward, speed up, slow down. These are the things we look at when given the graph of velocity. V of t is positive forward, V of t is negative backward. V of t is speeding up when I move away from the x-axis. V of t slows down when I move toward the x-axis. That's just graph reading at its best there. Okay. The next one we got here is when is the particle's acceleration positive? Acceleration. When is the particle's acceleration positive, negative, and zero? Well, now that I'm talking acceleration, okay, don't I have to look at slope of v of t to get that? Because acceleration is the derivative of velocity, therefore it's the slope of the velocity graph. I am positive whenever my, basically my acceleration is positive, because it's the derivative of velocity, whenever my velocity increases. So I can see I'm increasing here. I have a positive slope, so my acceleration is 3 to 6. My acceleration is positive from 3 to 6. And that's the only time that little pot licker is positive. It's negative whenever my velocity decreases. So I'm negative from 0 to 2. And I'm also negative from 0 to 6. Or excuse me, 6 to 7. I'm on it today. When is my velocity 0? Well, when is the particle's acceleration 0? Well, that is when my velocity would be constant, isn't it? So my velocity is constant right there between 2 and 3, and it's constant right there between 7 and 9. Okay, that's when my velocity would be constant. So I can gauge acceleration. When is my acceleration positive, negative, and 0 off of my velocity curve by interpreting the slope of my velocity. Yes, isn't that exciting stuff? Then, what's the next one we're going to do? When does the particle move at its greatest speed? Well, here we go. Remember, speed is the absolute value of velocity. And when I think of that, the most simplest way, absolute value of velocity, well, whatever speed is the absolute value of velocity. So whenever my velocity is negative, that just means it needs to become positive. So what I'm going to do is if I'm looking for the greatest speed, I am looking for the highest or the lowest points on my velocity graph. So I'm going to grab a line here just because notice my y-axis has no labels on it. So what I'm going to do is I'm going to make myself a measuring item here. There we go. Okay. And I'm going to grab that measuring item and I'm going to pull him here. Oh, looks like those are basically the same. And that's there. Okay, so my highest velocity is at time 0, and right there from 2 to 3 because it's driving constant at that rate. So my highest, let's get rid of that. I'm going to delete that little rascal off of there. I'm going to delete that little squirrel off of there too. So let's go. I'm going to go orange on this one. So my particle moves at its greatest speed, the time when at t equals 0. And, whoa, this is my n, and on the interval from 2 to 3. It's got the cruise control set on flat ground. It's just humming right along. What do we got here? When does the particle stand still for more than an instant? Well, if it's standing still for more than an instant, that would be when my velocity equals what? 0 for more than an instant. So when is my velocity 0 for more than an instant? Well, this is the velocity graph. My velocity is not zero there. My velocity is negative, but it does have quantity because it's not on the x-axis. Here's the only time I have zero velocity. Okay? So this is the only time when velocity is zero. Here I have no velocity, I'm zero, but that's just for the time instant at 5. Here I have it at 1, but that's just for that instantaneous moment. But from 7 to 9, okay, from the interval from 7 to 9, my particle is standing still. When does the particle change directions? Well, my particle is going to change directions. I know this when my v of t, when my velocity changes signs. Okay, what do you mean changes sign? Well, if I'm taking positive velocity to negative velocity, okay, I'm moving forward, then I'm moving back. I just changed direction. Or if I went from negative to positive, I'm moving back, now I'm moving forward. So when I have a change in the sign of my velocity, my function changes direction. Okay? So I have a change from positive velocity to negative, I change direction there. I have a negative velocity to a positive velocity there, change in direction there. Positive to 0, okay? But I went from positive, here, it didn't go from positive to negative, well, positive to 0. 0 is not positive or negative, so my particle just came, and it's like you pulled up to the stop sign, and you just sat at the stop sign, and you never left. So I only changed direction at t equals 1 and t equals 5. That's the only place my velocity actually changed sign. Whoa, I don't know what just happened there. So that is at t equals 1 and at t equals 5. Ooh. Okay? So the next thing, this is a little extra added extension to this problem. And given your velocity graph, we just want to sketch the acceleration on the provided axis that you have there. Now notice there are no quantities on my y-axis, so I have no way to know exactly what the slope is, because remember, acceleration is the derivative of velocity, so I know it's the slope of this line, and all I know is from time 0 up to time 2, I have a negative slope. I don't know exactly what it is. That's why I'm not putting any labels on my y-axis. Then, from 2 to 3, oh, it's horizontal. What is that? That's 0. So from 0, or 2 to 3, okay, my acceleration is 0. Then, from 3 to 5, look at that. That's rising, going up to the right. That's a positive slope. So somewhere from 3 to 5, I'm positive. And if you're curious, why are you putting those open circles when you started with the end circle? Remember, where you are non-differentiable, the derivative does not exist. And these are all sharp points here. Okay, if we had to find the derivative here is 0, the derivative here is positive. The left and right derivative do not equal, therefore I am non-differentiable at 3. So all these sharp points I'm non-differentiable at. However, the end point, we're only concerned with a one-sided derivative, and I know that's going to be negative. That's why that's a closed point on the end, okay? Now, from 5 to 6, whoa, why did I stop that at 5? I should have gone all the way to 6 there, shouldn't I have? Yes, you should have. So I have to make my open circle there. Make that come a little bit further. Then from 6 to 7, hey, check it out, I'm negative. So I don't know how negative I am. It looks a little steeper than the other one, but I'm not going to be that picky because we have no quantities. And then from 7 to 9, I'm horizontal. So from 7 all the way to 9 when I stop, I'm 0. So that's my acceleration graph. Okay, that's graphing my acceleration from my velocity. Okay, wasn't that fun? Come to the number 10 here. Now, particle moves along the number line shown by the graph below. The position P is given. The position, position function. Position is given as a function of time, okay? And what we want to know, when is the particle moving left? When is the particle moving right? When is it standing still? Well, let's check this out. Because it's the position function now. Because now I'm looking at position, okay? I am moving left. Think about it. You move left when velocity is negative. When velocity is negative, s of t, my position function, is decreasing to get a negative tangent, okay? I am decreasing from 2 to 3, and then I am also decreasing from 5 to 6. Therefore, the particle is moving left from there because s of t, the position function, is decreasing. It moves to the right when my position function is increasing, okay? So when is it increasing? It's increasing from 0 to 1, and that's the only time I increased. So I only increased, I only moved to the right once. When am I standing still? Well, that's basically standing still when my position function is what? When it's flat, okay? It's standing, sometimes I stand still for an instantaneous time, sometimes for long. Okay, also think position does not change, but time does. That's when I'm standing still. My position doesn't change, but time does. Here I'm at a position of 2 for a second, okay, for a whole second. So I stood still from 1 to 2. Okay, here from 3 to 5. My displacement didn't change. My vertical, I didn't change vertically. I just went horizontally for 2 seconds. So I stood still from also 3 to 5, okay? So that's reading a couple things off of your position graph. Last thing I want to do is I just want to come down here and I would like to graph the particle's velocity and speed based off of my position. So here's my position. This is going to be my v of t graph. Now notice, I do have quantities here now. Now I do have quantities. So I can see here from 1 to 2, okay, remember open circles on all these sharp points with the exception of the endpoints. I can see I rose 2, I ran 1, so I have a slope of 2 here, positive 2. So I'm going to make a closed dot at 2, and I'm going to make an open dot here at 1, and I'm going to say, there's my velocity. Now from 1 to 2, I'm flat. 1 to 2, I'm flat. That means from 1 to 2, I'm 0. From 2 to 3, ooh, I went down. I actually went down. 2, 4, I went down 4, I ran 1. Well, that's going to be a slope of 4 on this line, except it's going to be, because it's going down, that's actually a slope of negative 4 here. So I'm going to come down here, and I'm going to come down here to my negative 4 from 2 all the way over to 3. And I got to say, hey, I'm negative 4 there. Well, from 3 all the way to 5, I'm horizontal. The slope of that is 0. So from 3 to 5, I'm 0. And then from 5 to 6, I'm going down. How much did I go down? I went down 2, and I went over 1. So the slope of that is negative 2, I believe, right? So I would say, I'm going to come halfway between. I'm going to say, there's my negative 2. So I'm going to say, open, close. There is my negative 2. Okay, that's my velocity. All I need to do for my speed graph, okay, because this last one here is going to be speed. Remember, speed equals the absolute value of velocity. So all I need to do my speed graph is, I'm going to say from 2 to 1, I was at positive, or from 0 to 1, I was at positive 2. Then from 1 to 2, I was at 0. Then from 2 to 3, I was at negative 4. But remember, absolute value of negative 4 is going to be up here at positive 4. So then I go from 2 to 3. I'm going to be positive 4. Then 3 to 5, I'm still at 0. The absolute value of 0 is 0. And then from 5 to 6, I'm at negative 2 there, but that means I'm going to be a positive 2. So I go, and that is my speed graph. Okay? Now, that sums it up with graph reading. That's just a little couple problems to read graphs from given position. When am I moving left, right, standing still? Notice we didn't ask increasing and decreasing from my position because these are linear graphs. All these graphs are made up of lines. None of them are curves. Therefore, my slope was constant, so my velocity stayed the same. My velocity didn't increase or decrease in a way in which my particle would be speeding up, slowing down. Well, it does speed up, slow down on the other graph, but on my position, I can't tell that because the velocity is constant, okay? Because it's a line. So that ends this up. I will be back to you with some more derivatives of trig functions tomorrow.